Good afternoon. Welcome to course Thermodynamics of Materials. Today we are into lectures 179 and 180. We are discussing the copper sulfur oxygen stability diagram, the construction of this one copper sulfur oxygen stability diagram. We are set to draw 11 lines. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 lines. Out of which 5 were up to E, means 5 were already over. Okay. So today we have taken up the sixth one, that is copper CuSO4 equilibrium line. That means this line. This will CuS and this is CuSO4. Remember, CuSO4 is here. Don't miss this CuSO4. The rest you can very easily read this. Okay, this is oxysulfate CuSO4. So without wasting time, let us take up this CuSO4 gas phase. Before I take, actually I have to give you some errors, small error. Last class. Made in the last class. Which is nothing but, which is lecture 177-78. Here I made, actually I said the word metastable by the way, before I remember this figure 3 is not meant for this copper sulfur oxygen system discussion. Okay, this is actually the next topic, that will be example 3. That's why it is figure 3. So don't actually consider this and ignore this. Okay, look away from this, just consider this figure for our discussion. So last day I made a mistake. I said, remember, just to help you to be tuned up to, this is Cu2S equilibrium, this line, and this line is Cu2S Cus. These are stable equilibrium, Cu2S Cus, and here Cu and Cu2S. These are examples of stable equilibrium. But what is not stable, that is Cu and Cus. So they don't have actually a common line or any common boundary. So this is Cus. Actually, this equilibrium is a metastable equilibrium. So in that process, during that discussion, I by mistake I meant to say Cus is metastable equilibrium. This is correct, but what I said, this is Cu2S. This is wrong. This is not metastable. Cu2S is a stable equilibrium. So metastable would be Cus. Similarly, other cases. So you should be careful. Sometimes I mixed up with Cus and Cu2S, and again and with reference to stable and metastable lines. So you should be careful about that. That Cus is the metastable. Cus is the metastable equilibrium. This one, okay, and this is not. This is a stable equilibrium. Metastable Cus. Okay, this is a stable equilibrium. So okay, note this point. Another maybe 3 phase also. 3 phase I tell you, Cu2S, Cu2O. This 3 phase is a stable equilibrium. Three solid phases and gas phase, and they meet at a point called triple point B. But there are many metastable combinations of the 3 phases, namely Cu2S, Cus. They don't meet at a point. or say Cu, Cu2s, CuSO4, they don't meet. Cu, Cu2s, CuSO4 don't meet. Okay, what meet with CuSO4? CuSO4, Cu2s, Cu2O, they meet at D. This must be D. Yes, this is D. So Cu, Cu2s, CuSO4 don't meet, metastable combinations, three phase. Such are the examples. So if I made a mistake about Cu2s and Cu2s, so metastable, it should be Cu2s should be wrong. With Cus is the metastable. Cu and Cus are separated by a band of Cu2s, separated it. It will never meet. Depending upon temperature, they can be made to meet. That is different issue. So, but currently we see Cus is metastable equilibrium. I repeat, Cus is a metastable equilibrium. And another thing, at one place I wrote metastable. I wanted to write metastable, but I wrote metal stable. So this should be metastable. This is metastable. So you should take this point under consideration. So I remove this and I take up today's discussion. Today's discussion is copper sulfate gas phase. The F. This is the next consideration or next equilibrium that we consider two solid phase and one gas phase. The fifth, it is actually sixth in sequence. Okay, out of 11, this is the sixth one. So this is the equilibrium copper sulfide plus 2O2. Copper sulfide I have already written already today. Delta G06 is A plus Bt. A and B known quantities is minus RTL and KT. Or this gives you KT is known quantity. This means known quantity is activity of copper sulfate by activity of Cus, PO2 square. Or since these are one solid, PO solids are one activity. So PO2 square is a constant, or PO2 is a constant, or log PO2, since we are plotting log PO2 and log PSO2. So log PO2 is a constant. If it is a constant, that means it should be a log PO2 on the y-axis. I'm sorry, not this figure. Yeah, I'm very sorry. Not this figure. Log PO2, okay? Since we are plotting PO2 is constant, so it should be, or log PO2 is constant. Since we are plotting log PO2 constant means it is a vertical line. And this line is EF. So vertical line EF, constant. Along the line, what will happen? Along the line, obviously, this equilibrium will prevail, and both the solids, copper sulfide, Cus and CuSO4. So along the line, EF solids Cus and CuSO4 coexist. On the left of the line, Cus, and on the right of the line, CuSO4 solid are stable. Okay, on the right, what happens? Right means increasing oxygen pressure. If we increase the oxygen pressure, equilibrium will shift to the right hand side. So finally, it will eliminate copper sulfide, and it will maintain this oxygen, then higher oxygen. So then it will be copper sulfate solids the stable. The opposite will happen when oxygen pressure is decreased and copper sulfide will be present. So this present singly and this also present singly, but along the line both are present, both condensed phases, and the gas phase is always present. So shown on the y-axis and x-axis. So these are okay, copper sulfide. So note is the meeting place of. In the meantime, you note another thing is this on the right of the line is okay, are stable. Very good. Note is the meeting is incidentally the meeting place of three curves EG, ED, and EF. ED and EG were already discussed, and today we discuss EF. So E is the meeting point of lines EG, ED, and EF. So E is a triple point where three solid phases, namely Cu2s follows, Cu2s, Cus, CuSO4. Cu2s, Cus, and CuSO4 coexist along with the gas phase. Obviously, gas phase always present, as I have said, SO2O2. This much actually, F is over. Let me remove this. These are no use. Next we'll consider what? Next we will consider F, G. G will be which line? This will be which? Okay, follow this. This is over. So we may, okay, these are all over. So we'll take up this one, okay. Cu2O and CuSO4. Follow. Cu2O and CuSO4 means this DH line. This will actually note at the end, but we are considering Cu2O and CuSO4 equilibrium. So Cu2O, CuSO4 gas phase. So we should write correctly the equilibrium Cu2O well, let me check this. Actually G is okay. C2CO4 solid plus SO2 gas plus O2 gas gives you CuSO4. Okay. CuSO4 solid. To make a balance, Cu 2 Cu is there, so it should be 2 CuSO4 equals to 2 CuSO4. 2S there, but here you have to make it 2S. Then 8 oxygen, 8O. How many so far? 4 here, 1 here, 5, and 3 required here. It will be 3 by 2 O2. 3 by 2 O2. So again, delta, call it equation number 6, 7. 7. Delta G0, 7. Delta G0, 7. Again, A plus BT type, where A and B both are known quantities. A being delta H0, B being minus delta H0, is what? Minus RT ln KT. This gives you, this equation allows you to find KT is a known quantity, which is equals to, write nicely, activity of CuSO4 solids squared over activity of Cu2O solid times PSO2 squared times PO2 power 3 by 2. 3 by 2. 3 by 2. Now this is one unit activity, pure solid unit activity, or you are getting what? Or you can write these are one, or you see you have actually log PSO2 is, take a log on this, log PSO2, PSO2 is what? 3 by minus 3 by 4 log PO2, and this is log KT, again that also minus, but it should be half log K2, log KT, half log KT, okay. You need 2 PSO2, so to make it log PSO2, 2 log PSO2, to PSO2 you have to divide by 2, and this comes to this side and these go to the other side, and log means, log denominator means negative, so minus 3/4 log PO2 minus 3/4 log PO2 minus half log KT. Hence like last line, like okay. Hence, 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 hence the hence the log PSO2 versus log PO2 plot will be a straight line, will be a straight line, straight line with the slope of what? How much? -3/4. See, the slope is shown here, -3/4 here for this line. The straight line will be a straight line represented by line, represented by line DH, by line DH, by line DH, okay, along the line DH, like this, along the line DH, along the line DH, like, as you wrote before, along the line DH, solids which are Fe2O and CuSO4 coexist above the line, below the line, or even to the right of the line, to the left of the line. Above the supply right, above the line, along the line, first along the line DH, Cu2O, along the line, okay, DH, along the line solids Cu2O and CuSO4, right, like this, CuSO coexist, okay, coexist, and then on the above the line, above the line, CuSO4 solid, and below the line above the line, below the line, Cu2O, Cu2 solid or stable, Note, let us give a star here, and I think we can afford to remove these lines. These are all over. Note, on this, D incidentally is the meeting place of D just now drawn, DH, DH just now drawn, D already drawn, and DB already drawn. So D is last class, D already drawn, okay, and DH today drawn. So D is the meeting place of DE, DH and DB. So incidentally, so it is note D is the D is the meeting point of of lines. Tell me the lines, tell me. DE, DB and DH. DE, DB and DH. D, DB and DH. Okay, very good. Our lines D, DB and DH. So note D is the meeting point. This is a, so E is a, D is a meeting, so D is a triple point. Triple point. So this is actually, incidentally, you may note, B was the first meeting, first triple point. Today E, a moment ago, E is the second triple point, and now D is the third triple point. And I told you there are 5 triple points. That means 3 solid phase coexistence at a point. So this, and other 2 would be H and J that will come, okay, down the road. So this is a triple point. So what else you write? This is a triple where 3 solid phases, which are there? 3 solid phases, tell me. Take a look. Cu2s, Cu2O and CuSO4. Cu2s, Cu2O. Everything is okay? Look, checked.
Slight leg check the kid.
Oh, it's okay.
Otherwise, okay.
Bottom line is okay?
Yes, yes.
Cu2s,
21 minutes gone.
Huh?
22 minutes gone.
Okay, thank you. Cu2s, so 3 solid phases as you see. Cu2s, CuSO4, Cu2O. Cu2O and CuSO4. Where 3 solid phases coexist along with the gas phase, which is a mixture of SO2, O2. So we have completed G. G is over. Next is, let me remove this. Next we will take up G is over. H. H will be the next one. What is the H? You tell me which we should take up now. So Cu2O, CuSO4 is already over. So we may take up CuO and CuO-CuSO4, which is known as oxysulfate of copper. CuO and CuSO4, and they are divided by the line Hj. So that equilibrium we may consider next. Cu2O, CuO, CuSO4. So it should be like Cu2O, CuO, CuSO4, and obviously the gas phase. Okay, just wait a bit. I have to change this. Let us see if this works or not. Let us see. Cu2O, CuO, CuSO4. Okay. So Cu2O. What is this? Okay, I forgot to mention one thing. I tell you, I'll mention here. Okay, let us complete this. The slope I have forgotten to mention. This I'll write after we find. Okay, this will, how will you write this? Start. I do not know why this pen is not working. No, this is not working. Okay. Okay. CO2 better. Let's try this. CO2 solid plus SO2 gas plus O2 gas goes to CuO CuSO4 solid. So here what you see, 2 Cu on the right hand side, 2 Cu on the left hand side. How many S? 1 S and 1 S. How many oxygen here? 4 plus 1, 5 on the right hand side. And here 1 plus 2, 3 plus 2, 5. So it is already balanced. So to move like this, delta G0, okay, give a name to this equation. What name will give? 7, this is 8. E is 5, F 6, G 7, 8, 8. It's okay. So like this, delta G0, 8 is A plus BT, ET known is minus RT ln KT. Let us move this. This is actually repeated things. Okay. So let us go move fast. Okay. KT is meaning that KT is known is what? Right? Activity of oxysulfate, which is CuO, CuSO4, and mention that it is solid, and then activity of Cu2O solid, PSO2 and PO2. So let me space here. PO2. So this is one. This is one activity. The solids, pure solids, one activity. Or what you can write, or you see clearly here, log PSO2 is what? Minus log PO2 minus log KT. Call it equation. Okay, already know. You don't have to. So what is the, hence the, now what is the slope of this plot? Slope is what? Minus 1. I forgot to write this minus 1. 8J. This will be 8J. This is Cu2O and oxysulfate. Cu2O and oxysulfate. 8J. This slope I forgot to write. But in all cases I have written minus 1. Minus 1 as you see. So please mention this. So this is like this, hence like this, keep on writing. Hence the log PSO2 versus log PO2. Plot will be a straight line. Will be a straight line. With the slope of minus 1 represented by what? D sorry, HJ, the Cu2 and oxysulfate, HJ, by line HJ, it is better, by line HJ, along the line HJ, this is HJ, along the line HJ, use this along the line HJ, solids, which solids? Cu2O and CuSO4 coexist. Above the line above the line, who will be present? Above the line oxysulfate, above the line, and below the line Cu2O. Above the line CuSO4 solid. Why above the line means, actually we increase, or on the right of the line is what? As we increase PO2, if we increase PO2, oxysulfate. So if we increase PO2, oxygen to the right, so oxysulfate will be present. Or above the line also same. Above the line means PSO2 increasing. So if PSO2 increasing, so to the right, see, oxysulfate will be stable. Above the line oxysulfate, and below the line Cu2O, solid or stable. So we have completed H. Next will be I. HI. Which we will consider now? This is okay. It is good idea to consider oxysulfate and copper sulfate. Oxysulfate and copper sulfate means HK line. HK. So I will be oxysulfate and copper sulfate. So CuSO4 and copper sulfate. Is okay, and gas phase. So this, you can remove this. These are over. So how many already? This is equation number 8. 8 is over, 9, 10, 11. 3. This is the 9th is in progress. So how we write the equilibrium? Oxysulfate. So I am writing CuO. Sorry, yes, it's okay. CuSO4 solid plus SO2 plus O2 gas plus O2 gas is CuSO4 solid. How to balance this? There is 2 copper here, so make it 2 copper sulfate. Then 2 sulfur. You have already 2 sulfur. Okay. 8 oxygen. How many you have? 5 to 7. Then you have half. 5, 4, 5 O, 2 O, 7 O, 1 O. But 1 O2 is there, so it should be half O2. Half O2 gas. This is your actually the this is okay. We are actually discussing right, okay. So write as before, delta G0 Oh, this must be given a number 8. This should be 9. 9. So let us write delta G0 9. Like last time, A plus BT. Remember, A and B, each case I write, but A, B are different values. But then I have to write A prime and B prime, then A double prime, B double prime, A triple prime and B triple prime to distinguish one from the other. But that will be very difficult. Okay, that will require many actually primes. Also A1, A2, A3, A11, etc. But you have to understand that AB is actually the format, and these values will change depending upon the reaction. So this reaction and this reaction don't have the same A and B, but the format is okay. So known A, B, known quantity. That is what? Minus RT ln KT, from which you get KT is known. Known means is. Why known? I repeat, this is done for a given temperature. T is fixed. For example, I have given 1000 Kelvin. So if it is R is known quantity, T is 1000, A and B are known quantities. T is again 1000. So you can find out KT. KT is known. Write the expression for KT as you have written always. This is actually SuSO4 squared, this solid squared over CuSO4 the oxysulfate solid times PSO2 times PO2 power half. That's it. This is implied that this is under equilibrium. But anyway, this is 1 because pure solids, and this is another pure solid 1. So you can take a log and you can write this, or log pure. Oh, by the way, this reminds me. I write one thing. I tell you very easily. You can give me the slope. Remember, log PSO2 and log PO2 is plotted. So you will try to find log PSO2 will be log PSO2 will be the y is mx, x is log PO2, m is then -1. Why? You can justify from here. I tell you from here. See, for 1 mole of SO2, how many mole of A2 is involved? 1 SO2 against 1. So slope will be 1. And when it is negative -1, because they are on the same side of the equation. If they are on the different sides, then they will be plus. This actually in the previous case where it is plus, here plus, 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 they were actually on the opposite sides. But 1 against how many of oxygen? 1 SO2 against how many oxygen? You writing this, you will get the slope. In the log PSO2 versus log PO2 plot. Okay. See here, for example, what is this? So what will be the slope? You see, 1 SO2 against half O2. The slope will be half. But since they are on the same side, so minus half. And in fact, you see, if you do this here, log PSO2 is minus here, you do it correctly, half log PO2. Since it is denominator, PSO2 is coming to this side and okay to the left, and KT are coming down, PO2 down, so these are all negative signs. Minus half log PO2 minus log KT. KT, okay, you see. So this is actually the relation, and which gives a, so the, hence like this, just repeat this line. Hence the log PSO2 versus log PO2. Just keep on writing. Plot will be a straight line. Plot will be a straight line with the slope of minus half, with the slope of minus half, you know. Very good. Represented by line which line, tell me? Copper sulfate and oxysulfate by HK, by line HK. Along the line HK, both solids will be present, okay? Solids, okay? Solids which are oxysulfate, CuSO4 and CuSO4. CuSO4 coexist, and above the line means what you see, HK, na? Currently we are discussing which line? HK. Above the line means with higher PSO2. On the right of the line with increasing PO2, with higher PO2, higher PSO2, higher PO2. Below the line means lower PSO2. On the left of the line, lower PO2. So you can easily find out. Above the line, which will be present here, HK, copper sulfate. Here also, as oxygen increasing, as sulfur dioxide increasing, copper sulfate will be stable. Copper sulfate solid and copper sulfate solid, and below the line oxysulfate, CuSO4 solid are stable. Okay, this is okay, solid copper sulfate, and below the line is okay. So this is actually, so when you increase the sulfur dioxide, reaction move this way, and decrease means decrease from the equilibrium value, the value what you have along the line, what value you have, just decrease SO2 in this direction. So copper sulfate will be from oxysulfate. So on the left or below the line oxysulfate. So this is easy to follow. Next you take up Hij. So J, okay. Remove this. Remove this. I. Oh, sorry. I forgot. I'm sorry. I missed this. Give a star here. So HK over HJ. Moment ago HJ over HK over HDH is also over. DH is also over. Okay.
আর একটুও নেমে গেল।
একটু নেমে গেল?
না, it's okay.
Okay.
Lecture part is cut.
Cut off. Okay. Don't worry. I will be careful, more careful. Okay. Thank you. Okay. So I should know.
45 minutes cut.
Okay. So what I want to mean here, see, you see, incidentally, we actually come across another triple point. See, HK is complete, HD here, HJ complete, HD already complete. Okay, so HK, HD. So D is the H is the another triple point. So let's write it out. Note. I should have actually. Oh, I should have. I forgot to just note from this point. H is the meeting point of lines. Meeting point of lines. Which lines? Tell me. H is the meeting point lines. HD, HK, HJ. HJ just now, HK, and where is the HJ already? Huh? So write this HD, HK, and HJ. HK, HD, HJ. Huh? Of lines HK, HD, HD. H is a triple point. H is a triple point. Where three solid phases. Which three solid phases? Tell me. Oxysulfate, copper sulfate, and Fe2O. Fe2O, CuSO4, and oxysulfate. CuO, CuSO4 coexist along with the gas phase, which is SO2A2. SO2O2. Okay. So let us highlight this. I forgot to highlight the previous three already over. I forgot to, but now I remember. So I have been careful. Highlight the triple point. How many triple points? Remember, 5 triple points. Okay. So 1, 2, 3, 4, 5th is coming. So that's why I have it. SO2, this is over. Okay. Next, you will take up what? Tell me what you will take up next. Next, you will take up. This was what? I means J. Next is J. J is what? This was which one? I is what? 9. So this is the 10th and 11th. The concluding one. J will be what? Tell me what? J will be, you might do this thing. Cu2O and CuO. Cu2O, Cu. Bring CuO into picture. Cu2O and CuO. Higher oxide and lower oxide. I hope you can see this. This is CuO. CuO. Let us see. CuO, Cu2O, then next CuO. This is not taken care of yet. And gas phase. I'll write this. Tell me. Cu2O plus O2 gas. Oh, sorry. Solid plus O2 gas is obviously 2CuO solid, obviously, and this will have the level of 10th equation. So start delta G0 as before, like this. Delta G0 10 is A plus BT, known quantity, is minus R T ln Kt, which leads to Kt being a known quantity and which can be expressed as ACO squared over ACO2O times PO2 at equilibrium, but it is understood. So since these are solids, this is also solid, they are pure, 1, activities are 1. So what you get, or remove this, or what you write, PO2 is constant, or PO2 or log PO2 is constant, okay, Ij, okay, wait a bit. PO2 or hence log PO2 is constant, or constant, then that must be represented by a PO2 constant is a log PO2 is a constant, means vertical line. Which vertical line? It is here Jm. Therefore this is shown here Jm constant, vertical line as mentioned here, Jm. Along the line Jm, what will happen? Solids, which solids? Tell me. Cu2O and CuO. Cu along the line, Cu coexist. Above the line, above vertical line, it cannot be above. On the right, on the left. On the right, which means higher oxygen, the higher oxide. So CO or C here, as oxygen increasing, CO will be stable, and as oxygen will be reduced, decreased, CO2 will be stable. So on the right, above it is not correct. On the right of the line, which is stable, CO solid, and on the left of the line, CO2O solid are stable. Single phase stability. So you should understand, all this whole thing is a stability diagram, equilibrium diagram. For example, here it is single phase, single condensed phase, and the gas phase, accompanied by the gas phase. So single condensed. So in terms of condensed phase, suppose I say this is here, this is also stable. Here, see, along, okay, put this way, along the line AB, yes, copper sulfide coexist, and there is an equilibrium there, copper plus sulfur dioxide plus copper sulfide plus oxygen, that prevails, that reaction prevails. Fine, very good, we are happy that that reaction is in equilibrium, and they together, both the condensed phase together along with the gas phase. Below the line doesn't mean it is non-equilibrium. Below the line also, below the line, one of the two that is in equilibrium, means two condensed phase equilibrium is disturbed, dismissed. One condensed phase equilibrium, so copper below the line, and above the line another condensed phase, Cu2S and the gas phase, and here below the line copper solid and the gas phase are in equilibrium. So equilibrium does not mean that both Cu and Cu2S are in equilibrium, and that equilibrium is actually ruptured, that equilibrium is disturbed, that equilibrium is upset, that equilibrium is made invalid. Let it be. and we'll get a new thing in equilibrium, single phase. And now if you extend this, not only two phase have to be, it can be three phase equilibrium, three condensed phase equilibrium, along with the gas phase. Three condensed phase, copper, Cu2s and Cu2O. Where? B. Where all the reaction between this and this, between Cu2s and Cu2O, and Cu2 and Cu, all three coexist, all simultaneously coexist. This is the idea. So the whole diagram is a stability diagram. So are stable, okay. So J is over. Now H, this is 10, last one. H will be what? Tell me which one is still left? Copper oxide and oxysulfate. I mean CuO and oxysulfate. Yttric oxide as you call it. Higher oxide. CuO and oxysulfate. So let me write that. CuO oxysulfate. Solid I don't write here. Gas phase. This is the final one, last one. I'm sorry, final. Last one that we will take up, and we are going to complete the construction of the stability diagram. Let me check this is okay. CuO oxysulfate gas phase. Okay. So start. CuO, let me write this way. CuO solid. Plus you have to add sulfur dioxide gas. Okay. Plus O2 gas is CuSO4 solid, and give a number to this 11. Yes. 11. So tell me 2 Cu but 1 Cu. Must be 2 Cu. And about sulfur then, how many sulfur here? 1. So it's already balanced. So how many oxygen here? 5 oxygen. So how many? 2O, oxygen means O. 2O and 2O, 4O, but this is O2, means 6O, but make it half O2 means 1O, so 5O, so balanced. So start delta G0, 11, A plus BT, A plus BT, A and B known, and B known, okay, as before, is minus R3 ln KT gives you KT is a known quantity. Is what is the expression for this, right? Activity of oxysulfate solid over activity of CuO squared solid squared times PSO2 times PO2 powered half. Okay, or from this you get what? Tell me, or you can write this, or in the form of log PSO2. Oh, tell me, using the same principle. Okay, what is the slope? What I said, you can get the slope. For one SO2, how many O2? Since SO2 on the y-axis, y is mx plus c. For how many y? For one y. For one y is mx plus c. Y is mx plus c. What is the slope? For one y, how many x? So here, one y means for one SO2, log P SO2, so actually one SO2, one in the reactant is SO2. So one SO2, how many O2? One half O2. So slope is half. But since they are on the same side, minus half. Okay. Another thing I avoided here actually, SO2 is not there. But here it is so easy, straightforward, that it is a vertical line. So vertical line means slope is vertical line, slope is infinity. Because for 0 SO2, 1 O2. So 1 by 0. Here half by 1 is half. So here 1 by 0 is infinity. So slope is infinity, means vertical line. So anyway, you have understood. Let us see it will come. So log P SO2 or log P SO2 is what? Minus half log PO2 minus log KT. So you can write it that way along the line. Okay, so write this is, so write this, hence the log PSO2, hence the log PSO2 versus log PO2 plot will be a straight line with the slope of minus half. I have shown here, take a look. This is CuO and what is it? CuO and oxysulfate means CuO and oxysulfate, this line JL. What is the slope I have written here? See here, C minus half. So minus half. See here, minus half. So with the slope of minus half, okay? With the slope of minus half, represented by line JL, represented by line JL, line JL, along the line JL. What is your comment? Along the line JL, who are present? Both solids coexist. Along the line JL, solids, copper oxide, cubic oxide, CO and oxysulfate, CuSO4 coexist. Above the line which is oxysulfate, above the line CuSO4 solid. Again above the line means higher sulfur dioxide pressure, you can see sulfur dioxide increasing, oxysulfate is stable, and above the line oxysulfate, and obviously opposite will happen below the line, and below the line means sulfur dioxide is decreasing, and below the line, which one? CuO solid are stable. So lines are stable. With this we have finished the 11th line, but this gives rise to the last triple point, another triple point, or the last triple point J, because JL just now over, we already have JH and JM here, and JL and JH is already, so JH already, JM here, and JL now. So 3 lines and they meet at J, so that is the triple point, 5th triple point. So I should give a star mark here. I remove this. I don't remove. This I don't remove actually. Should I remove this? So double star if I give, will it help you? Double star, because this is only a this okay, format of these sentences, this type of sentence I will write here. Okay, for the triple point J. So I am writing analogous manner exactly here. Double points from this. This is the previous one. So note what J. J is the meeting. So just you may copy this meeting point of lines. Which lines you tell us? Tell me. JH, JL, JM. JH, JL, and JM. JL and JM. Okay. J is a triple point. Where three solid phases namely which are there? Here, three solid phases Cu2O, CuO, and oxysulfate. See, Cu2O, CuO, and oxysulfate, they meet at J. Three solid phases Cu2O, CuO, and oxysulfate. SO4 coexist along with the gas phase, which is SO2 Fe2O2 mixture. So here, as I have said, I wanted to highlight these 5 triple points. I forgot to highlight the previous 3, but these 2 I have highlighted. Okay. So what are the 3 triple points? Repeat once more. B, D, E. B is where 3 solid phase. What are the solid phases? Repeat. B, copper, Cu2S, Cu2, meeting point. D, what are these? Cu2S, CuSO4, and Cu2O. E, Cu2S, Cus, and CuSO4. These 3 already. And 4th, H, written here. 5th, J. 5 triple points. And I showed you that there are actually total number is possibility is what? How many? 35 perhaps. If I remember, you remember how many I said? 35 perhaps, no? Yes. 7C3. 7C3 is okay. Yes, right. 7C3 is 35 total possibilities. Total combination possible 3. Out of 7, 3 at a time, 35. But 5 is actually seen as stable triple point. Remaining 30. 35 minus 5 is 30 are metastable triple points. For example, I will repeat. Suppose it randomly see copper Cu2O, Cu2 and copper sulfate, they don't meet. Copper Cu2 it does not meet. Copper Cus, copper sulfate don't meet. Copper CuO, oxysulfate don't meet. You get 30 such combination. These are all metastable triple points and don't show in the diagram. Okay. So with this, we have completed this construction of the diagram. Yes, I should remove this. I should remove this to write the conclusion line, because we are all set. Let us remove this. These are not required at all. Okay, so the final diagram, this is the final comment. The final diagram is shown in figure 2. This is the figure 2. I have written here stability diagram for the system copper, sulfur, oxygen. This I said. Okay. This I said, and many other things I have already explained. Is shown in figure 2. Shown in figure 2. After removing the metastable lines, and retaining the removing the metastable lines and retaining the stable lines. That's it, and that's it. This is over. So example 2 is over. But I tell you, don't mix up with this. I use the term metastable on here also. How many 30 metastable? I said metastable combinations. I said, and they are not shown, etc., etc. Similarly, metastable three-phase combination, 3 continuous phase combination arrangement, or similarly metastable two-phase combination. This I say. There is no metastability about single phase. All single phases are present. 7 C1 7 and 7 is showing 1, 2, 3, 4, 5, 6, 7. It's okay. About two phase there are some metastable lines, and for three phase grouping there are some metastable. These are not. I have removed here what I mean. The metastable lines which are considered a stable triple point. These lines are all stable. Here actually a metastable extension. Metastable extensions are removed from the diagram. Metastable extensions are, and retaining only the stable ones. I am showing you one by one. Here what are this diagram? See, always you think why it is here, why it is not coming all the way. This is metastable extension. This is metastable. This can be shown by the compatibility, mutual. They are mutually consistent, stable lines are. Metastable lines are not. They conflict. They are in conflict. This one I said. Another is thermodynamically activity is higher activity corresponding to metastable, lower activity corresponding to stable lines for a given state. So if you consider this is metastable, this is also metastable extension, and there is also another. These are all metastable. So finally delete them. Okay, these I have taught you how to find them very easy. Every other. If it is stable, then it is metastable, stable, metastable extension. Similarly, not only here also you may suppose these three are stable. Here also you can bring into question. This is extensions. Metastable extensions are removed. This I said metastable extensions. So what is the metastable extension for the vertical line? And this is not vertical. This is a -3 slope. Slope, negative slope. What is the extension? Down, down, down. Extend it. Just extend. Extrapolate. Extend. How will you extend this? How will you extend this? How will you extend this? Damn easy. These three will form a metastable group. Oh. So everywhere. I am showing you here another one here. H is so triple point. Around the triple point, they are arranged. 3 stable, 3 metastable. Every other are stable, every other metastable. So what is this? What is the metastable extension of this line? What is the metastable extension of this line? What is the metastable extension of this line? check this and you see they will be incompatible. So that's I wanted to say. I remove this. Okay. So with this, now finally we have to remove the metastable ones. But let it be there for a while. Okay? If you or say, well, I should finally remove this, because this is for construction purpose. Then once you are confirmed that these are metastables and should be removed, you will remove them. Okay. For example, you will remove this. It should not be shown in the diagram. Diagram will not show there. Out. I think no harm. You understand this. Okay. Like this. This is okay. So no problem. See, since you understand, no problem. If it is there, still since it is dotted means this is dotted means this is metastable line. So no problem. Even if I, it's okay. It's okay, don't worry. Thank you very much. We have completed this copper sulfur oxygen system. This will be very useful in copper making. Okay, to have a full concept of this copper making from this sulfide to metal, or oxide to metal, or sulfide to oxide to metal means copper. So this under hot condition during roasting, copper sulfate will be formed. So we want to make in hydrometallurgy, copper sulfate will be water soluble, easily soluble. So we want to make copper sulfate. So under hot condition we have to roast. So these diagram will give us an idea of this. Okay, will give us a good idea of this. Okay, and will allow us to find the condition, the gas pressures that we should maintain to have the required product, like say copper sulfate. Okay, for example. So suppose we want to produce copper from copper sulfide. Copper sulfide, you remember what is the known name? It is white metal. From the matte, when you actually oxidize, the first product that is actually you get. Okay, Papa?
No, the word lecture 179, 180, that is totally here. From February it is visible.
Now?
February 20 is visible. Now totally gone.
Everything?
No, lecture.
Course is there.
Nah, course is also gone.
I'm just checking. This is okay? No problem.
No improvement.
Doesn't help much, no?
No.
And help much?
No.
Okay. But no lecture, no course. Or?
No lecture, no course. Starting from February, that is the first line.
Thank you. But otherwise okay?
Otherwise okay.
Bottom side is
Bottom
okay.
is okay, fine.
Thank you. So this is over, and what I said, so white metal.
1 hour 20 minutes.
You see. So what I wanted to tell you, that suppose matte melting, you get what matte is what CO2S APS. Then you do blowing, converter blowing. First stage of blowing removes APS and leaves behind CO2S. Then if you want to oxidize that, you continue blowing, then it will pass through copper, and if you have continued continue the oxidation beyond a point, when it is already converted into copper, but still you continue, then it will be copper oxide, CO2. That you have to careful. You have to control blowing. And if you, I am telling you this, if you blow under this condition, your oxygen here though, under this type of condition, then CO2S2 directly CO2, there is no scope in high pressure. At a high pressure, CO2S will be converted into CO2, not CO. So careful about the pressure, that may be too high. Maybe the normal oxygen pressure may be here. So it goes through from this side, oxygen has to increase. So starting is CO2S, the matte, white metal that you call C2S moves, change to copper, passing through copper. So many things to be understood from this. Copper, then if you continuously, copper, you are maintaining, say, oxygen, say pure oxygen, for example. So its pressure is here, very high. So what is the stable state? It will be CO2 past, even CuO. But your desired product is Cu. So what is done? When CO2S is blown, it is gradually converting into Cu. After it is converted into Cu, then it will be CO2. But when it is before it start oxidizing, you have to stop your blowing. So that it is finally copper. And that too, remember, under this condition, not this condition. I mean higher pressure of oxygen, then it will be CO2 pass into CO2. These are the knowledge. A similar thing in the LED steel making. If you blow for removal of silicon, carbon, other phosphorus, etc. So and iron is also oxidized. If you blow beyond actually say, oxygen pressure, if you actually for an extended period of time you blow, then it will be all oxide. Suppose iron will handle oxide. You want steel, but at the same time you have to blow for a limited time. Okay, so that your only these impurities are removed. Okay, that is also multi-component system, and this is there also. So, but I principally said, so you have to, since you intend there to remove, say, silicon, see, phosphorus, carbon. So when you are applying oxygen to remove them, using oxygen, injecting oxygen, iron is also will be oxidized to some, because it cannot be escaped. But you have to see that up to what extent you have to, what duration you have to blow. This is different discussion that maybe a POMNO, okay, that equilibrium diagram, stability diagram we will consider as the fifth example. Okay, this is now second example is over. So don't worry. So this with this actually I said there is a lot of application in roasting. You will have the application. Remember, you might argue that yes, sir, the copper uses matte, white metal, copper liquid, but this has no application. But this diagram is not relevant to that. Converting, matte melting, converting from the matte, because they are liquid phase, but this is for all solids. So you may argue that. But here, I am giving answer. But before that, but for solid, roasting is a solid state with the gas involvement, solid. So if you roast, then this you can apply. Under what condition your desired product is copper sulfate, you will produce. This is there. And if you argue for some matte, but this gives an idea how you should be careful. Only thing what you have to change this to copper solid to copper liquid. CO2 solid to CO2 liquid, you have to redraw a diagram. And CO2 liquid. Then you will have an idea. Okay, this is for solids actually you have shown. So one example you get, you will be able to, that's why it is easy, it is required that you learn how to draw the stability diagram. Just ask softwares to draw the diagram for you, then your concept will not be clear, will not be complete. Will not be complete, and you will lack confidence. You will not be used well. Okay, so here you have variously you can use, since this is all you have drawn yourself. And this type of simple diagram you should draw yourself. For complicated things, you may take help of softwares. Okay, thank you. With this, we move on to the next one. So, second over. System copper, sulfur, oxygen is over. So, we'll start with the third one. Third one is what? Iron, carbon, oxygen. System carbon, oxygen, involving, I'm writing this, involving, I'm writing this. Before this, let me remove this. Let me remove this one. Let me remove this diagram first of all. So this is over. These are all over. Remove this. Remove this. Remove this. Remove this. Okay? So let me actually so it will take I'll shortly start this. Good idea if I remove this. Is okay? Bapu? Hello, Bappa? Come on in. Just check once more if it is okay. Even same? Even the same? To? Huh? No problem.
No problem.
I remove these things like that. This,
It's okay.
Okay, though? ठीक है.
1 hour 29 minutes gone.
Okay, 29 minutes. Okay, very good. So, what is this system Fe2O involving what? Fe. Start. Example 3. Okay, 6 examples will be considered. Okay, 3, 4, 5, 6. Fe2O, Fe3O4, Fe2O3, and carbon. All pure solids. All pure solids and the gas phase. What is CO is there? What is the gas phase? CO, CO2. So this is the system Fe2O, and this is the diagram, corresponding diagram. So before let's first go through this, run through this diagram Yeah, and these we will construct all these lines. That is the lesson. That is our objective. But as if we have constructed, again I am explaining you. See, title is Figure 3, Stability Diagram for the System APCO. The title, the objective, the capsule of the example. Temperature on the x-axis, percentage CO in CO2. That is sometimes not written, but you should note that it is in CO2 percentage CO. So this should be careful. Okay. If nitrogen is present, then you have to think the modifications. Okay, or you have to apply properly, suitably. So that is another issues coming. Another issue may come, and that may come. So percentage CO on the x-axis. What I have shown? See, one by one. G, C, first of all, A, B, C, D, E is what? This is the, I have written here. What is that? Carbon saturated carbon. What is the reaction? CO2 plus C solid is 2CO. The representation of this reaction, this you know, you are used to this. And this is a pressure sensitive equilibrium. So pressure is considered as 1 atmosphere. Only one pressure we have considered 1 atmosphere. Okay. So, but pressure sensitive. If we change pressure, it will shift. These are all discussed number of times. And also you should note the carbon saturated means activity of carbon solid is 1. So 1 is okay. What is this is the A, B, C, D, E. What is the other? Now 3 lines you consider. G, C, F. This is the equilibrium between 2 condensed phase, Fe solid, FeO solid, and the gas phase, always. Similarly, G, D, H is the equilibrium between FeO solid and Fe3O4 solid and the gas phase. The way we have done in this case, copper, sulfur, oxygen. And what is the third line? GJ, the equilibrium between Fe3O4 and what I have written here on this top, Fe3O4, 2 condensed phase. The equilibrium between Fe solid and Fe3O4 solid and the gas phase. So once you have these 3, then you understand this is there will be a triple point. G is the triple point. And again, extensions if you draw the extension, that they are metastable extensions. Metastable extensions. I will remove that because they are metastable. So remove from the stability diagram. This is the stability diagram. Okay. Good, very good. What else? Another line normally not shown in books. You may not see many papers, but rarely you may find. But I have, for this purpose, but these students may be interested to know where is the Fe2O3, the starting oxide, background, highest oxide, Fe2 hematite. Where is that? This is shown here. This line EK, right? EK is that line along which Fe3O4 and Fe2O3 coexist. The equilibrium between Fe2O3 and Fe3O4 and the gas phase is given by EK. Actually, why the books don't show, I tell you what. This is actually almost merged with the x-axis, not discernible, much discernible, not easily seen. I slightly enlarge it for viewing purpose, but maybe okay, it is good idea to show this. I will refer to one paper, okay, one paper actually authored by my student and along with me. So that paper there, this is drawn very nicely and exact with data. There also it is actually almost close to x-axis, but still it is all the same there. So that reference I will give you later. But for the time you don't worry about this. Then what else? I give you 3 points, three points, critical points. See, that is this carbon curve intersects the FeFeO curve at C. Carbon curve intersects the FeCO4 curve at D. Carbon curve intersects this EK curve at E. This C, D, E, these three critical points, why I am telling you. These I will mention in the note, but I am giving you actually an outline so that you will be interested about this. This C, I have given you exactly the description of C. C is nothing but about 58.9% CO. And temperature is 966 Kelvin. This C is 58.9% CO here, this C, and temperature is 966, about close to 700 degrees centigrade. D is likewise 42.7% CO, 922 Kelvin, this C. And E is obviously gas actually, is almost 0% CO, and temperature is 321. So, but another thing I forgot to tell you, percentage CO, it is from 0 to 100, is quantitative I have given because we know the data. So there is some advantage. So that's why I gave you 0 to 100, and this is 300 to 1300 because these are after data. Actual data, in fact, I will give you alongside. So you have no difficulty. What comments I have made? One comment I have made here, just one comment. So this zone is what I told you. To the left of this ABCDE curve is a very important metallurgical curve. Important curve for metallurgical students, blast furnace students, or say direct reduction students. Very important curve. Okay. So okay, that is ABCD. This is carbon saturated curve. That reaction is CO2 plus C is 2CO. That equilibrium is shown by this curve. About this curve, and to the left, I told you, to the left or above, whatever you call it, to the left or above this zone, what is called, what is that? I told you, what is the activity of carbon? You remember, it is greater than 1. And this what happens here? Shooting. I told what? Shooting zone. This is shooting zone, means this gas is unstable. You cannot prepare any gas of this of the composition given on the left of this curve or above this curve. They are unstable. They will fall back. Now here, you will fall back on directly. Suppose you keep the temperature constant, fall here. Unstable gas. So origin, shooting, unstable gas composition. And what is additional? Activity of carbon greater than 1. That's why this happens. Okay, so it falls back. Is unstable. This gas we cannot prepare. So where? To the this zone, to the left. Right is okay. So activity of carbon along this curve is 1. Carbon saturated. I should write here. If you don't mind, I write here. So already carbon saturated means activity of carbon is 1. But still, if you like, since I have written activity of carbon is greater than 1, this is not required. Carbon saturated means activity of carbon is 1. Also, carbon solid I have given here. I'm right. Additional writing. Okay. Okay. And this is greater than 1. And below, on the right and below the curve, ABCDE curve below, right, activity of carbon is less than 1. And these gases are realizable gas, and practical gases, no problem, absolutely no problem. So anyway, currently we are not studying carbon oxygen system already. Over we have started. Only we are interested in FeCO. We will involve iron, and we have involved this. So next job is what? Construction. That how do you get these lines, sir? How do you get? Now answer is we will have to draw the curves ourselves. So this I will do. So start. How do you start? How do you start? What you have learned? Start with N max. The planning of the diagram. So as you start as before, to begin with, before M max M is C minus P minimum plus 2. What is that? C is 3, P minimum is 2 plus 2. Why it is so? Why it must be so? See, you write that. C is 3 because it is a iron, carbon, oxygen system. Okay. Okay. This is okay. Very good. Very good. Very good. Okay. APCO, C is 3 and P minimum is 2 high. P minimum is 2 high. One condensed phase must be minimum. Is it here? So this is one condensed phase. APO or here AP, here AP3O4. 1. Minimum is 1. It can be 2 also along the curve. 2 along a triple point. On a triple point it is 3, but minimum is 1 condensed phase and gas phase unavoidable. So CO2. So 1 solid and 1 gas phase. So 2, 1 solid phase, 1 solid plus 1 solid and is okay and 1 gas phase. 2, how much it is coming? 3. See, what is the idea? We don't want to, minimum you have to present 3 variables or 3 dimensional diagram necessary, but we don't go for that. What you do? We fix 1, plot 2. Fix 1, plot 2. What will you fix here? What you fix? See, temperature is axis, it is not fixed. So it is, this time this pressure is 1 atmospheric pressure, I told you. So fix 1, pressure. And plot 2, what is the plotting? Percentage CO and temperature. This not necessarily percentage CO, it could be PCO. And first of all, percent means mole percent. Percentage CO is, I am writing for you. This is mole percent. To be clear, mole percent CO. It can be or XCO, the mole fraction, CO temperature, or PCO temperature. Many possibilities, but percentage CO is actually very helpful. Okay, directly get percentage. So it is mole percent CO, or XCO is a mole fraction. So if you know percentage and mole fraction is separated by 100, factor of 100, and PCO is also what is XCO is PCO over total pressure. So PCO versus T as well. Okay, so anything you like, but we concentrate on this. This is. So what else you want to do this? Now construction of the diagram start. Construction of the diagram. From here, start here. Construction of the diagram. One by one, you take up equilibrium. Equilibrium what? You can consider APO, and the gas phase. APO, gas phase. Means you are interested in finding this line, GCF. You are interested to draw that line where APO meet. GCF gas phase. Let us see what is the equation. What is equation? Why? How do you get this? In non-linear, it establishes everything exactly mathematically, so that you can draw accurately. Gas phase. Happy? Quickly move on. Gas phase. Gas phase means what it contains? Tell me. CO2. Fixed one, that is what I said. Fixed one is pressure. Okay. Dividing line here. Okay. CO2. What is equal to how you write? FeO. Tell me. FeO solid plus CO gas. Very easy. Goes to Fe solid plus CO2 gas. And call it equation 1. Start. This example 3, equation 1. Okay. So delta G0 as before, delta G0 1 is which form? A plus BT. A plus BT. These A and B are known quantities as you write. Incidentally, this time, since I have all data common, very popular, so I will give you. These are very common and okay. So I am giving you that data if that helps you. Okay. So what is the data? A plus BT is, you may note this, is minus 17,230 plus 20.88 T joule is what? The tell me is what? You know, minus RT ln KT. KT now mark here. KT1 maybe, I hope. KT okay, yes, not is not required here. Okay, maybe later. Okay, is minus RT ln KT. Okay, this is better actually. I like here. RT ln KT. Okay. A plus BT minus RT ln, this known quantity, this is minus RT ln K. Okay. This gives you what it gives you is minus RT ln K. I am writing. Okay. Since T is not fixed, I am not writing actually, but it is K is a function of temperature, RT ln K. I am writing here. Expression for this RT ln RT ln K, expression for K I am writing here, so no problem. AFE solid PCO2. You can write KT here, but actually normally I wanted to mean when the temperature is known, but this temperature is variable. So we may write, or I will drop this because we are actually expanding it into activity numerator and denominator. PCO2 activity FeO solid PCO. Our intention is to find relation between percentage CO and temperature equation. K is expressed in terms of this PCO2 PCO form, which you will get percentage CO. Let us see how. Okay. So this is one pure. This is one. This is what? Minus is absorbed as what? RT ln PCO by PCO2. Oh, sorry. We don't have to write gas. PCO over PCO2. Remember, A and B are known quantities. I have given the data also. This is the A, this is the B. A is minus 17,230 and B is 20.88. From data book. This is okay. Or you write this, what you will write here, or RT ln PCO by PCO2 is A plus BT. Okay. That's all right. Or RT again, you must write RT again, PCO by PCO2, A plus BT is A plus BT, or PCO by PCO2 is what? PCO by PCO2 is what? Tell me. Exponential A plus BT over RT. Happy? A plus BT over RT, okay? Or continue. Or PCO over PCO plus PCO2 will be what? Tell me. Exponential A plus BT over RT by exponential A plus BT over RT. In denominator is what? Denominator 1. Your denominator was C2, so PCO plus PCO2. Denominator 1 is what? Plus 1. This is known as what? This is known as PCO plus PCO2. This is known as XCO. XCO is this. What is mole fraction CO or mole percent CO? This is what I wrote somewhere. Mole percent CO. Percentage CO is, this is mole percent CO. So, okay, mole percent CO. So this is mole fraction CO, or right, or mole percent CO is nothing but 100 times this. So write that nicely. 100 times exponential A plus BT by RT over exponential A plus BT over RT plus 1, and this is actually mole percent CO or percentage CO or mole percent CO. Or you write percent CO first of all, XCO percentage CO, because we write, we often refer to percentage CO, but then you write here, this is nothing but mole percent CO. I already mentioned, percent CO is mole percent CO. It is not volume percent, mole percent, okay, mole percent CO. So this is very, very useful relation. Call it what? This is equation 1, then this outcome is equation 2. This represents what? This is for what? Which curve? This is the equation for the curve Fe2O equilibrium. Fe2O means GCA. This is the equation. Percentage CO on the y-axis versus T. You can easily do yourself by calculator. Consider certain compositions and temperature, find the percentage. Different temperature, different percentage, then connect with a smooth curve. Generate this curve. Or you can use some program. Okay? So GCA, you can use some program also. Software. Or simple calculations, no problem. So given this, very good. So equation, so what is this? Right, let us write this. What is this equation? Hence, this plot is what? Non-linear, and that's why you get this GCF is a non-linear curve. Okay, so that's right. Hence percentage CO versus T. Okay, you extend this box and bring in 2 inside. Okay. The percentage CO versus T plot is non-linear. Non-linear as you clearly see, and given by the curve GCF. Again, like before, like copper sulfur oxygen system, along the curve, above the curve, below the curve, along the curve, along the curve. Tell me what will happen along the curve. FeS and FeO solid coexist. Okay. Above the curve, Fe solid is the stable phase, and below the solid, below the curve, and below the curve, FeO solid is stable. Okay. So why this happens above the curve? You see, follow this curve. Above the curve means what? I say along the curve, FeO both. Above the curve means percentage CO increasing. If CO increases, which way? Fe towards Fe. So Fe is stable above the curve. Below the curve, the other way CO decreasing. Other way FeO stable. Means here, written here. Written means here, anywhere here, FeO stable. Along the curve, Fe. So one curve is down. So next day, second day, B, which one it will Babu, almost done. 30 seconds, 1 minute. Next day, what will happen? FeO, Fe2O3, next will pick up FeO, Fe2O3. Still next, Fe2O3, Fe. The Fe2O3 here, this curve. Fe2O3 and Fe. 3. 4th would be what? Tell me. This is Fe2O3, Fe2O3. 4th, 5th would be what? The carbon curve, ABCD. So these 5 curves will be considered, right? Then we will have this diagram and we will make some comments and all these things. I will give you a reference to this, okay? Reference paper, next class, okay? So let me write this. B is next day, equilibrium Fe, almost seconds only. FeO here, Fe2O3 gas phase. Up like to is okay, Fe2O3 gas phase. Okay, to gas phase CO2. CO2. Okay, is okay. Gas phase is next class. This is next class. Today we will stop here. We will take up from B, and C, D, E. Total 4 curves will be complete, and this diagram will be completed, and some discussion will follow. Thank you very much for your attention, interest, and sincerity, and your patience. Thank you. See you next class. Bye.